Hey guys, it's C-Mac here. Today we're going to build real-time Spring Boot React application. So this tutorial is going to be a complete working web application. I'm going to start using Spring Boot and use it to work as a backend platform. And I'm going to connect it to database, everything you need to know, and then connect it to a nice React application. However, in the next video for the next week, I'm going to have a full Spring Boot application. So everything full Spring Boot backend and the front end. But in order to show you guys how full stack software engineers, build real life applications, since React is very, popular these days. So I thought it's a better idea to actually do one video with React and Spring Boot. So this is very exciting. Without further ado, let's get started.
All right, guys, before I actually start writing the application and jump into the code, I want to walk you through, all the pieces and things that we're going to see in this video, and also all the steps that we need to take if we want to take this app to the next level, which I'm going to show you shortly how this is going to work. So we're going to build an expense tracker application. This is going to be a very easy application. The purpose of this video is just to show you how Spring Boot can integrate with REST API, and how we're going to plug in the React component or any other UI framework, so you guys get a good and clear understanding of this architecture. So in this example, as I said, we're going to start building the application using Spring Boot. And as you can see here, Spring Boot is going to basically talk to our database, which I'm going to use H2 database. So we're going to use JPA, and the one thing that I want to mention about JPA, a lot of people ask this question, okay, so what if, what's the purpose of JPA, right? Java Persistence API is basically, it's a wrapper around JDBC. So back in days, we used to write very complex queries, right? And those queries can get really, really complex and heavy. And it's really hard to understand if you join a new team and you see like thousands of, stored procedures and different, complexities around the database layer. So JPA's goal is to basically make the database interaction very simple by using the beans and connecting the beans annotations like one-to-one, one-to-many, many-to-one. So these are the things that we use in JPA, and we connect those beans. Basically, we connect the Java objects, and then we start, working with them, and we basically use dependency injection in Spring Framework to make this interaction with database much easier. So a lot of people ask question, okay, how do I write this complex query in Spring and JPA? Of course you can by annotating the query in your repository layer. However, the whole purpose of using JPA is to just use the API in order to communicate with the database. So in the example, you will see how we connect and how we get data. It will be so simple, and you will see how easy we'll interact with database without writing any selected statement. So another layer of this application, of course, is being a gateway to our database. Basically, the whole purpose of having the Spring Boot application is to provide an external interface to other applications, to other web browsers, to other command line interfaces, to other APIs, to other systems in our architecture, so they can talk to our system via this API. So we are kind of like hiding all the complexity behind these four HTTP methods. So REST API, once you see here REST API and HTTP, REST API is just the architectural style on top of HTTP protocol. So HTTP can handle protocols like get, put, post, and delete. And once you expose this, these methods to any external system, they can basically talk to your system. So if on the left side, if I do have a system working under Python, it doesn't matter, because they can integrate and they can talk to each other very easily via the HTTP REST API. So this is the entire architecture that you see. On the left side, I put all the possible things that you can interact. We're going to use a tool called Postman in order to basically test our application. If you haven't watched my first video regarding Spring Boot application, REST API, I definitely recommend you go watch that first and then come back to this one. But if not, then it's completely okay to proceed. But it's better to watch that one so you have a better understanding. As you can see, I have a React or other UI framework. So React is a JavaScript framework. It's a very advanced, and it has a great state management system. It only updates the pieces that basically React tells the browser to update. So it's very efficient. And React does have something called virtual DOM. So it's a map, it's a shadow of a real DOM, right? And when you modify the React application, the virtual DOM gets updated and tells the browser to actually update the DOM in the web browser. You will see this as we progress in this example, but I just want to give you a quick tip here so you guys understand what's happening. So you can use any other framework on your choice. It doesn't matter. I'm going to use React. I will have another video just to have a Spring Boot full front end and back end application, so you guys can learn about Timelift, template engine, and how exactly Spring application works. That's going to be my next hands-on video. So anyways, let's proceed here. So now you guys know, we can communicate with this API, and on the left side, we can have any system that basically uses HTTP protocol and can communicate with our system. We're going to expose few methods like, get expense information or, a bunch of things. So we can actually post and delete and add some data to our system. So this is our final architecture. As you can see, React is going to, talk to the Spring Boot application and then talk to the database. And we're going to use Bootstrap, to make our app look good, and especially for mobile apps and things like that. Well, this is going to be a working version, and it's going to be enough for this tutorial. But this is not only a tutorial. I want to make this really simple for you so you guys understand how big companies, how real life examples really work. So how do we take this example to the next level, like world-class applications? All right, let's have a quick review. I am not going to cover these in this video. However, if you guys want me to, go over all these concepts, these can be like really different topics and can get really complex, but I'm willing to put the work and, show you guys how all these components can work together properly in order to make a real life application. Well, so, in the past, we used to build one big application, and that was a very challenging approach, because if you want to change one part of the application, you have to deploy the entire application. If you wanted to update one form in your expense, for example, page, you have to upgrade the entire thing. So that has changed a lot. The modern applications, they all use an approach and architecture called microservices. Well, what's good about microservices is if you are building a system that's loosely coupled, it has very small component. They do one thing and they do one thing really well. For example, in our example, if you look at bank microservice, it's only focused on banking stuff. It doesn't have to deal with for example, expense or income component or user profile. So this is very great because the components, they stay very small. Different teams can work on different modules at the same time without conflicting each other's work, since they all going to be talking through API, through HTTP, and some put post get methods, which they are very, very simple, right? So and then what happens here, we can actually scale the part of the system that we're getting a lot of traffic on, or we're putting a lot of loads on. For example, let's say for some reason overnight we get million users, right, in our application. So we don't have to scale the entire application. We can just only scale the user profile microservice in order to react to that immediate traffic spike. So microservices, it's a very extensive topic, but I will cover Spring Cloud that basically it's a Netflix library, and they've mastered this design, and I can basically, I will show you how to use Spring Cloud in the next videos to how to basically develop microservices using Spring Cloud, and you will see that's going to change the way we think about software development. However, there are a lot of challenges along the way, so we need to think about how these services, they talk to each other. What if this service fails? It's going to cascade the fail, and it's going to take the entire system down. How do we scale the one piece? How do we keep track of routing? How do we debug this application? So there's a lot of awesome, great topics that hopefully I will cover them in one video, but we'll see how this goes. But let's take a look at the expense application that we're about to build. If this was a real life application and we wanted to really build a business around this idea, so the way we had to develop this system is to basically scale the system for any potential spike. So the technologies can be used with this architecture, as one of them is Docker. So Docker is a virtualization around at the OS level. I'm sure you guys know about virtualization at hardware level, which is basically you can run virtual machines on one piece of hardware. You can have 5, for example, 10, whatever virtual machines on your hardware. However, this concept, Docker, is basically takes the same concept and takes it to the next level, which is OS virtualization. So imagine you have all these microservices that they're running on different ports: 8001, 8002, 8003, and 4. So basically, you can run all these 4 applications under one machine using Docker. So Docker basically will provide an isolated environment for expense application that it's running under port 8001. Well, so let's review again. Let me go slowly. So you have 4 components. They all can run under one machine using a technology called Docker. Docker will provide an isolated environment for each of these applications that are running on different ports. So using one operating system, if you have one server, you have one operating system, you can run different applications. You can have database application because the virtualization is happening at the OS level. Well, there are technologies. What if the amount of traffic, what if we scale, if we go to 1 million users, how do we deal with all these Docker, machines that we have scattered around, everywhere? So the technologies we can use, of course, one of them is Kubernetes, and one of them is Amazon Elastic ECS, which is basically a container service, Elastic Container Service. So the entire thing is we want to have a cluster at the end. This cluster with a bunch of computers that are running bunch of Docker images, and they're serving our applications on specific ports. Let's say if you're scaling your user component, and you have like 10 instances that are running, you have 10 applications running on different machines. So who's gonna basically orchestrate the entire process? So that way we can use Kubernetes or Amazon ECS. Basically a cluster that manages all these machines that are using Docker images. Okay. Let's move on. At the database level, of course, our main database, we're going to have a database that all these services that can talk to different databases. If you see, I have a black and red, square around the database, and that means we can have different instances on different regions. For example, if you're in the US, you can have a database on West Coast and East Coast. That makes your database highly available. If something happens to East Coast, you can still send all the traffic to the West Coast. So these are all advanced topics. I just want to give you some idea about how real applications work. You can have read replicas. So let's say you just want to read some banking information and you want to have a high performance. Your main database is basically handling a lot of traffic. You can create read replicas in order to serve just read traffic to the users using this read replica without hitting your main database and affecting the performance of your application. If you get really popular, if you become the next Uber or I don't know, any other big startup that they started with very little platform, then you will need to use some technologies like Redis or memcache, that they basically help you cache some information. So let's say one thing becomes popular in your application, and then users want to read this data over and over and over. Instead of hitting your database, you can just store it in cache and serve information from your cache back to your users. Of course, you can use MongoDB if you want to store only JavaScript objects, or you want to just store JSON objects or document objects, not relational database like SQL Server, or you can use DynamoDB. So those will be, the real life applications that use these technologies to basically load profile or load document style, or basically data that doesn't have specific schema. We can later I'll walk you through all these. And then at the end, of course, you can use the technologies like if you're running on AWS, you can use technologies like Route 53. And if the users the traffic is coming from East Coast, you don't have to come back and hit the database in the West Coast. You can just hit the the database on the East Coast in order to provide a better performance for your user. So this was just a high level basically approach, high level architecture that I wanted to share with you guys, so you guys understand how the real life applications operate, and how do they handle huge amount of traffic. This is how they do it. These are the technologies that a lot of companies use. But we're going to go back to our example, and as you remember, we're going to talk about Spring Boot application. In the first phase, I'm going to build the Spring Boot application that talks to a database. And the database, it's going to basically expose some HTTP methods. Very simple. We've done this before in our in the other video, but I'm going to review and build this application again, so it's a practice for you guys, so you guys can stop the video and practice and come back and watch it again to make sure you're 100% comfortable with this, with all these concepts. And then at the end, we're going to build a UI platform using React that talks to our Spring Boot application and calls all these methods in our REST API. So let's start coding. All right, we're going to start by going to start.spring.io. And once we're here, we're going to select Maven, Java 2.1.5, com.example.codeengine. All right, and then I'm going to name this project Express. So this project, basically I'm building it on the fly. You might see me, debugging, stopping, troubleshooting, things like that. This is a real demo. It's not a pre-built application. So we're going to move on by selecting a web dependency, which is going to help us create Tomcat, RESTful, and Spring MVC application. Since we're going to connect to the database, we need a Java Persistence API, and we'll be using JPA to connect to our H2 database, which is an in-memory database. You can connect to any database of your choice. In this example, in order to keep this tutorial simple, I'll be using H2 database. I'll be using DevTools since when I change something, I don't have to restart the service, Tomcat, so it will automatically pick up the changes and it's ready to work with. So one last thing I want to add, it's Lombok. Lombok is basically a very, very helpful a dependency which removes a lot of boilerplate code. And when we build classes in Java, we have to set getters and setters, and of course toString method for every single class that we build. And that's why we basically let other components from outside to talk to our classes, and the concept of encapsulation and abstraction. So Lombok basically helps you just annotate the variables, and it automatically creates all the setters and getters and toString, and which is very, very nice and convenient. However, if you want to get it working, if you haven't installed it yet, once you download this project and you open it, you need to go to your local repository where your POM POM file downloads all the jars. go to your C drive, local user, find your username, and underneath the M2 in repository.org, you will find the project Lombok, and then click on the jar. It does have an install option. So you select the path if it hasn't selected by default, and then select the path and click on the install and then restart your STS. I'll show you here in a second how. So, but this was just a extra piece of information in case if you use it and your app doesn't work, you know why. We're going to go ahead and download the project. And I'm just going to extract this guy to a different place where I have my STS connected to. There it is, right here. So let's actually, there it is. Let's select this and extract. Okay, we extracted the project. Now we're going to go to File, Import. Since it's a Maven project and is existing, we're going to select that. And of course, we're going to select Springboot. And here's a POM file that is selected by default. And I'm going to hit Finish. And as you can see, Spring STS is going to download all the dependencies for this application. And if you take a look, we have all these different components from our Spring Boot application. All right, so if you go back to pom.xml, you will see that we have all the JPA, Web, DevTools, H2, and Project Lombok. This is what I told you about. So if at this point, if you don't have, it's the first time you're using Project Lombok, you can simply go to your C drive, and in C drive, you can go to users, and then you can go to basically M2 repository, and then select org, and of course Project Lombok. Once you're in Project Lombok, then you can just simply go ahead and run this jar. You will see an installation thing, and it will start picking up all these paths, and then click on the install and follow the installation. So simple. Then restart the application, then Lombok should be working properly. Okay, so just to review our API that we're about to build, again, our Spring Boot application is going to be the back end of this application. So what we see here, we know if we annotate the class with Spring Boot application and we put the run method, so it's basically telling Spring that this is our entry point to the application. And we do have an application, the property, which I'm going to add a few things. One of them is basically it's show SQL commands, because when we use JPA, we want to be able to see what commands we're running. And the next thing that I want to basically activate here is H2 console. I'm going to enable that so we can access to our in-memory database, and you will see it shortly. So I'm going to go and create a new package here, and I'm going to name this controller. Well, in the controller, I don't have anything yet. I'm going to have another package that it's called, instead of controller, it's going to called model, which I'm going to put all the beans and all the base classes in this guy. And I'm going to have another package which I'm going to put all the repository, which is all database connections. So I have 3 layers, MVC, right? Basically model and controller, and I mean view is going to be different, but the concept is just to separate all these packages. So as you're building your application, you're not going to have issues recognizing the place of your program. So let's move on, and we're going to start by creating a few models here. And you guys know, and the reason we build all these classes, because we want to create different beans. So obviously we're going to have a table in the database for all these classes that we're putting in models. So in the expense tracker application, I'm going to have a user class. whoever's using the app, there's going to be a class called user. So obviously I'm going to annotate this with entity. That means I'm telling JPA and Spring create a table on the database side for me. Okay, so let's move on. We're at the first class that we're going to actually create is called user. Okay, for user, what we're going to do, we're going to actually start creating some fields. So private, it's going to be private long ID. What else do we have? We have private string name, and I'm going to add their email address. Private string email. Great. So I have 3 fields here, and I'll be creating some new classes shortly. But before we move on, I need to annotate this guy as an entity, so JPA knows that my intention is to build a table on the other side, which is a database. I'm going to name the table, and it's going to be name. It's going to pick the class name, but I'm going to just tell JPA what name I want to use. So here's the beautiful part for using Lombok. Take a look. I can simply go here and tell Lombok that I need getters and setters, right? And it's going to create setters and getters for name. I mean, we already know we can go back to source and go to create getters and setters, select all these guys, and then hit OK for every single class. And so we're going to have a bunch of code sitting in our classes. But Lombok's goal is to actually remove those, extra setters and getters, and automatically it will generate it behind the scenes for you, so you don't have to have more complexity in your code. And what actually makes this actually really better, Lombok has something called data, and take a look. It says generates getters for all fields, a useful toString method, and a hash code, and implements it. So basically, when you use data, it automatically handles pretty much everything for you, so you don't have to deal with anything here. Well, one thing to remember, if you're not aware of this, I mentioned this in my last Springboot development, which was a RESTful API, that if you don't put no arg basically constructor, JPA, it's going to give you an error. So in order to make JPA happy, you need to have an empty constructor. Again, we know we can go back to source and go to construction, or just create the construction here. But by just putting this annotation, automatically Spring is going to add it for you. So for users, I'm going to just add generates the all argument constructor using all the fields. So we have 3 fields. This will basically create a constructor using all of those guys. So well, the thing that we need to think about here is how we're going to connect this guy to other components. So let's proceed a little bit. We have a user, right? And that user underneath, it's got some categories. Let's say we want to have categories: travel, student loan, car loan, mortgage, food, movies, I don't know, whatever category the user want to put expense under that. We're going to build actually those categories, and we're going to keep them in a database. So the first thing we need to create is to actually create the category bean, right? Category class. So we're going to annotate this guy again with entity. We're going to say the table name is going to be name equal to category. And of course, we're going to have no argument constructor to make, of course, JPA happy. Well, one thing I forgot to add in the first class, which it was basically adding an ID to this guy. So basically we want to have a primary key, and of course you can add generated values. So this generated value basically provides for this specification of generation strategy, value of the primary key, which I'm not going to use in here because I'm just going to supply the ID for now manually so we can understand the concepts. So the next one, I'm going to have another ID for this guy, which is going to be ID. Great. And this is our category @ID, and then we're going to have private string name, and again I'm going to annotate this class with data using Lombok, and then Lombok automatically is going to create all those getters and everything that I need for this guy. Also, our category is going to be just simple ID and name. So imagine we're going to have a table that has the category ID and category name. Category name can be something like travel, or can be something like grocery, right? Or any other thing. So these are the categories that we're going to connect to the users. So now we need to connect these beans together. So imagine you have a form, user wants to select a category. So we want to have all the categories that the user, worked in the past or has item underneath, expense item underneath. So how do we connect the user to category? Well, that's actually very simple. If you actually think about it, a user can have many categories, right? I hope this makes sense. So one user, since we are in user class, so we start with that class. See, the class name is user and we start with one. So we say one user can have many categories. So since it's a categories, I didn't say category, I said categories, right? So one user can have many categories. And so we're going to have a set of categories, right? And make sure you're importing this set from java.util. So set is basically removes all the duplicate values to make sure we don't have two travel, otherwise we could use just, a normal array list or whatever you want to use. But here we're going to use a set, and as you can see, a collection that does not contain a duplicate element. So we're telling Spring that we're going to wire these two components, a user and category, by using a one-to-many. It's one means, so you look at the class, it's user. So the first part of this equation goes to the class that you are inside and working on it. So it says one user, two many categories. So which makes sense when you think about it. One user underneath has a bunch of categories, and those categories, since there are more than one, we're putting it in set. Otherwise we just couldn't store it as a category type. Okay, so let's move on now to the next step. So we connected our user to category, but we haven't connected our category back to user. Well, so here we have one-to-many relationship, and guess what? On the other side, you have many-to-one this type, right? Relationship. So many-to-one, many categories can be assigned to one user. Well, we're going to also add a cascade type, which is going to be cascade type dot, or we're going to just use persist. So these are just different cascade types. If you select all, so basically you're cascading everything, all the operations. Whatever happens on the left table happens on the right table. In this case, we're just going to go with the persist. So persist operation is basically it's going to be cascaded throughout this operation. And the reason, because when you add the user or when you add the category, you need to add the user. So this relation does not exist without this connection. So the persist need to, we need to make sure it persists in both tables. So let's review once more for the last time between category and user. So user, took a look, category, many category, this is how I read it. So I start with many categories can be connected to one user. it makes sense because user has. So of course, on the other side, we saw that we have this relationship, but instead of many to one, this time we have one to many, because the English, that if you pay attention to the sentence, I say one user has many categories, and on the other side, I say many categories is under one user. So the relationship makes sense now, and we're good and done with these two classes. The last class is, of course, is called expense. So underneath of the category, we're going to have expense. Let's say under grocery expenses, you want to have like 6, expenses for different timestamps. Or if you travel 3 times a year, so you're going to have, I don't know, a bunch of records underneath the travel category. So what we're going to do, we're going to create a bunch of fields again here and continue building our expense model. All right, so we're going to go with private long ID. And of course, we're going to annotate this with ID. And we know the drill. It's going to be entity. So JPA is going to create a table, and we're going to say @table. We're going to put the name equal expense, right? And then we're going to have @no args constructor, and we're going to add also all constructor. So we have it, and then we're going to move on with our setup. So we put the ID here, and of course we want to add data. So Lombok will create all the getters and setters and toString and equal everything. It will write it. So one annotation basically removes a lot of code that is actually necessary, but it's just you have to repeat it all the time. Well, let's think about here for a second. We need to have a private field that basically keeps the timestamp, right? So I'm going to use something called instant, and you will see shortly how. Expense date. So this is the date that we're going to stamp the expense, and this is coming from a time object. So basically this is used for, just a timestamp. As you can see, it's a point on the timeline, right? So you just pin the time. So it's good for timestamp. Of course you can use other type of date time on your choice, but this exists in Spring. You can use it. The next one is private string description of this expense, right? Traveling to Vegas, going to New York, visiting Grand Canyon, things like that. And now at this point, we need to connect this expense to 2 things, right? The expense should be connected to a user. So we know, this expense is for user CMAC. And it needs to connect to a category. So we know it's under travel category. So if you think about it, if you have an expense that's called, let's say, I don't know, 6/16/2019, right? And then you're going to have an, visiting New York. And then you're going to have the next field, which is going to be, so we did the date, and let's say you have an ID of 1000, just a random ID. And then you have the date, you have visiting New York. Now you need to connect this to user. Imagine you have a user that has an ID of 1. So you put the user, so we know this is related to user number 1. This is how we connect the data together, right, on the database side. And then you're going to say this is under category of traveling, and the category ID is 10. So this is going to be basically ID of this record, which is PK, primary key. It's going to be date. After that, it's going to be description, and it's going to be user ID. So we know this expense is related to user number 1, which is ID of the user, and of course, category ID. So we know, imagine, category ID 10 is travel. So we use that as a foreign key, basically, to connect the data together. So with this architecture, your expense record, every single record, has a user connected to it and category connected to it. right? Makes a lot of sense. So how do we do that in real world? It's very simple, actually. If you think about it, we need to create two more connections, right? So we're going to say many of these expenses can go under one category, private category, right? So many of these expenses can go under one category. Let's say if you spend $100 on, I don't know, a car loan, right? So you cannot put the same car loan under student loan. It doesn't make sense, right? So all those expenses, they should be under one specific category. So we say one category, since we only can put the expense under one category, but we can have many car loans. You can have 3 cars, and all the 3 expenses goes under one category. So that's why the relationship between the two beings, it's many to one. This is basically a SQL join, right? But it's underneath, it's happening. JPA and Hibernate is handling it for you. You don't have to deal with the database layer complexity. We have one more relationship, of course, which is one too many, and you can tell me, guess what it is, and it's yes, it is user. Well, we say one user. Again, the translation, always the right side goes to the variable, the left side goes to the class name. So expense, many expenses, take a look, many, this is how we read it, many, we start with many expenses goes to one user. So a user can have many expenses, right? So we basically put the ID of the user, we put the ID of the category, and a bunch of other data. So this way we connect relationship between category, expense, and user. We are pretty much done with our class design for this application. So this is our back end. And now we're going to move on and we're going to create a bunch of dummy data, and we're going to put them in database. We're going to run this application to make sure it's running, and then move on. And then we're going to create the controllers and create the RESTful API. Once we finish the REST API, then we are ready to connect our UI, which is a React application, to this backend. Perfect. So let's move on, go to application properties. Remember we have these two, so we can see the SQL commands that JP is initiating on behalf of us for all those many to one, many to many. All those relationships is being handled by JPA. And of course, we have this guy. So I'm going to create a file here under resources, and I'm going to select the SQL type, and I'm going to call it data.sql. And I'm just going to put a bunch of insert statements here, and just to test data. So I'm going to pause this video so you don't have to watch me typing all these statements, and then we'll take it from there. All right, guys, we're back, and I've inserted 3 users, just the random users, right? And then I have a few categories, travel, auto loan, and I'm going to put this, I don't know, student loan category, or grocery, whatever you want to put in. And then in the expense table, if you recall, we had ID, we had the expense type, we have the timestamp, which is 16, 15, and I'm going to put this 14, so we have a different data. And then the next one is, of course, user. We're going to have it connected to different users. So user connected to user 1. And then it connects to category number 1. So we know under travel category for CMAC, I visited New York, for example, on this date, and the expense is being recorded. And of course, same thing, category number 2, it's auto loan for Ford Mustang for user number 2, which is John. And then 3, it's Grand Canyon for the user Adam, and then we have ID of number 1 for the category, which is connected to travels. So you can simply see the connection between the data model. Before we actually run the application, we have to create one more thing, because we don't have any database connection at this point. So the way we do that, we start with the CRUD repository or JPA repository, which is basically an interface, right? And we're going to go category repository, right? So in category repository, all you need to do, you just extend JPA repository. Well, and it's going to ask you, okay, instead of T, which is a generic type, what type you want to put in? I'm going to say the type is going to be category, right? Remember, we are trying to connect a category to the database, and it says, is this the same category in the model? I'm like, yes, it is the same thing. And it says, what's the ID type? I'm going to say the data type is long. So in JPA repository, once you extend JPA repository, everything is handled by JPA. This is very beautiful, right? So simple. Now you have a connection to database. See how simple. So this is category, right? And it's basically using this bean class to connect to database. So we are mapping this class to a database table. So Java object is being mapped to a database table. This is the art of JPA, Hibernate. You convert Java classes to database table and vice versa, right? So and the type is category, and of course the ID of our category, the type is long. So I tell, okay, when you connect to this table, the primary key type is basically long, right? So I'm going to add just one quick thing to this table. I'm just going to say the category, return a category when I ask find by name. And I'll tell you right now what this thing does because it's so simple. So I'm saying return a category when I ask for it. When I pass you a parameter and ask for the name, you send me back the name. And the way this find field works in JPA, so you add the find by, and then you add the field name, right? So we have a field called name, right? And if you go back here, you have a find by plus field. But the way we put the field here, we just turn the first letter in the field to caps. So if you look, this is going to be find by, because find by is just a constant, always is going to be find by. And the name, instead of name all lowercase, the first letter is going to be caps. This is how you basically search the table. So this is how we connect to database, and our JPA is ready. I think everything is all set. We can actually go ahead, hopefully no error, and give it a try. So what I'm going to do before I run the application, I go to update. I might have some of these jar files locally, so it won't take a long time. Yours might be the first time. It's going to take some time. And then when you're ready, we're just going to go ahead. We're going to right click on this application, and then we're going to run this guy, and hopefully without error, we should be able to see the results. So the application is starting now. All right, so we have an error here, and we'll take a look at it shortly. But before we proceed, let's take a look at this guy. So you see Hibernate is basically creating, dropping, and adding a bunch of tables here, and creating all these foreign keys for me. If you've ever worked with SQL Server, you know all these things that you have to reference the foreign key in the first table, in the second table, connect to prime. These are all being handled by JPA, so you don't have to deal with any database complexity because you're only working with beans in your application. Well, this is a live development, and again, I haven't prepared this application before, so this is how it works out in real work, because I want you guys to see the application. It's not always the happy path. We see errors, we have to understand how to debug them, how to find the problems. So let's go ahead and see what's happening. In this section, as you can see, it says in the table category, it says table category not found, right? And if you go back, let's close the CRUD, close this guy. There's no error in user, and there's no error in expense. I'm just going to focus on category table. Well, so in category table, what is this saying? It's saying the category. So we connected this category to a user, which we don't have to, right? Well, the category can be just it doesn't need to be connected to a user, specific user, because we already built that connection between expense and category. So I added first, but now it's probably not needed. I'm just going to go ahead and remove it for now. And let's go back to our data set. So this is our user, this is our category, and that's the, so we basically, let's remove this for now. I know I mentioned that we're going to connect these beans, and I hope it was useful for you, but at this time I'm just going to remove it and keep this simple. We could actually connect that. I'm going to leave that to you, but for purpose of this application, I want to keep it as simple as possible so you guys understand the base concepts. But I hope my explanation when I was connecting the user bean to category was helpful, so you guys learned it. So let's go back to category. We still have an error, and it says name and category. And if you go back to our data, so insert into category, and we have an ID and actually I misspelled category. That's what it was. So let's go ahead. Hopefully we can run this application for now. So basically we connected the user. We have an expense table that has a reference to user and has a reference to category, right? So we know every single expense is connected to who. Perfect. So we have no error. And as you can see, JPA created all these guys, and now it says the application is running under Tomcat port 8080. So our application is running under Tomcat port 8080. I'm just going to go ahead and start the application, see if it works. So if you go to localhost -h2 console, you'll be redirected to this guy. This is your H2 database. And if you connect to it, you see we have three tables in here, right? JPA added this to database by using that JPA repository thing and H2. So since we annotated three classes, category, expense, and user, JPA created all the three in the database. And if you run it, I have some data populated. So we have category 1, 2, 3, auto loan, and this and that. Of course, the second one is user. We have 3 users in the system. We might have more or less. And then, of course, we have a selected expense. So we know every single expense is connected to a category and to a user. So we don't have to connect the category directly to the user because we're putting all these data together in the expense table. So now we're going to go ahead and start creating our controller. The first controller we're going to build, it's called category controller. So since this is going to be a REST controller, we're going to annotate it with REST controller. We're going to add request mapping /API, since we're going to just separate this layer. So if you go to /API and then followed by whatever map we put underneath. So this is like basically prefix. So what we're going to do, we're going to create a private field to our category repository. So since we need a connection to database, I'm going to name it with category repository. Perfect. So in category repository, we're going to build a constructor using fields for that category repository, and here our constructor. So basically, we're going to pass this guy, and we're going to set the local category repository field, and so we can talk to our database. So let's start by creating our first get mapping method, which is going to be to get all the categories. And then what's going to happen here, we're going to actually have a method called categories. And what's going to return this guy, it's going to return a collection of category, right? Because it's going to return a bunch of categories. This can be a bunch of lists. All right, so I'm going to use a collection interface instead of list, so we can have a different implementation of category. And then this is going to basically return, the category repository, category repository dot find all. So this method is basically to equal select all from category table on our database side, right? But you see we're not writing any SQL because JPA and Hibernate automatically under the hood, it's finding all the tables for us. So we're just using the pre-built JPA repository file. Okay, let's restart the application. I'm going to use a tool called Postman. I'm going to go to localhost 8080 localhost 8080 slash API, since I added it, categories, and then issue this command, and hopefully we get all the categories that, yes, that's the case. We got all the categories as a JSON response from our database. So this is very cool, but let's take a look at a few things here. So the response has headers, has body, and has some information attached to it. So this is basically a response entity. Response entity means status code. Take a look. It says 200, which was successful, and it has a header section, and it has a body section. So the entire package, if you put all these things, the response code like 200, header and body, everything in one box, we name it response entity. And you see in the next method that we're going to basically pull one of these categories, we're going to have to use this as our response strategy. So let's proceed. What if I want to get like category /2, right? Because I do have an ID of 2, so that should return the category of 2, which is auto load. So the way we're going to do it, we're going to go with get mapping again, and this time we're going to say /category, right? And then we're going to say /ID. So this is how we pass a variable and we put it part of our application, part of our URL. So since this is a path, it's attached to path, we name it path variable, right? Path variable. And then, as I mentioned, this method, it's going to return response entity, and we're just going to use a generic one, and we're going to say get category, right? And @, it's going to be path variable space long ID. So what I'm saying, you pass the ID of type of long, because my category accepts only long data type, right? And it's path variable because it's attached to the path, to the URL. It's part of the path. That's what we use it. And then once we have that guy ready, now what we're going to do here, let me add some space here. We're going to say, we're going to return category, right? And this is going to be category, right? Because it's one category. It's going to be category repository dot find by ID, right? Because ID, it's going to look like that, and the ID that you just passed to our method. So if you see here, there is one problem here, and Eclipse is recommending me to convert this to type optional. And the reason it says to convert it to type optional, because we don't know if this IDs exist or not, right? So if you convert something to optional type, it means it's optional type of category. It means it might not, return anything. That's why we put it in optional, right? Very simple. So now we're going to say return this category guide that you just returned if there's a value, right? And then we're going to use a function called map, right? Basically, we're going to create a stream and then return all the values from there. So we're going to create a lambda, basically, response. And we're going to say pass this function. This is the variable name, and it's going to be a response entity dot OK. So if we get OK and the status is OK, create a builder with the status OK. If there's a response, return it OK. And then in the body section of that, put the result, which is the response, right? If that doesn't happen, right, we can say or else. We're going to create, if we don't find anything, we're going to have a new response entity of basically HTTP status dot not found. I think okay, the response is going to be empty, and then within this guy we're going to put HTTP status dot not found. If we don't find anything, we're going to go with not found result. So let's move this to the next line so we can understand what it does. So it's very actually simple if you pay attention once more. So I explained this line. It's going to return the category, and the reason it's optional because it might return nothing because the ID might not be valid. And then we're going to return the result that we got from the category. If there is something, we're going to map it to response. And the response is going to be response entity. If it's okay, put the response in the body and send back to the browser. Otherwise, create a new response entity. Again, we mentioned response entity is the header, body, plus everything, right, in the box, and send it back as status not found to the browser. So let's go ahead and test this on Postman. Again, we're going to issue the same command. It's working. Now we're going to go ahead and category /1. Perfect, and it's returning number 1. And look, status it's 200, it's successful. It's got header and it's got body. That's a response entity for this URL. Let's issue number 3. Perfect, we're getting student loan. It's finding by ID and it's optional. It's returning the response entity. What if I put /300? Well, what's happening, as you can see, our new, let me go back and make sure you understand this. Our new response entity not found, take a look. It says not found, 404 not found. So I am building a response entity and sending it back to the browser, putting nothing in the body, and it's got headers. As you can see, content length is 0, but it's a response entity, but the status is 404 not found. So this is very easy. Now you see how to create a response entity and send it back to the browser. We always work with response entity. Remember this. Now we're going to go ahead and to see if we can post actually a new category. So it's going to be category, right? And then again, we're going to build a response entity as usual, but our response entity, we know it's going to return a category because we're adding a category, and we're going to return at the end that category back to the browser. And we're going to say create category, all right? And then we're going to say we want to make sure the request that is coming to our application is valid first of all, right? And I'll show you shortly how we're going to do that. And we're going to say at request body, we're expecting a request, and it's going to be embedded inside the body, and we're expecting to see the category, and we're going to name it category. Well, let's review it once more. You're expecting a valid request body, so you're expecting a well-formatted data coming into your application. If someone adds, I don't know, a subcategory to your data that is coming into your application, your category doesn't know anything about that subcategory. It's not defined here, so you're going to get an error. And the way we're going to actually validate this, I'm going to say this is not going to be null, and you see you must provide a name. It cannot accept any null value. So here Spring will make sure you are receiving a valid, since we annotate that with non-null, request body of type of category, and then you're going to name it category. So this is a data type, and this is a variable name, right? So if something goes wrong, we're going to actually send through this exception. It's going to be URI syntax exception, which is going to let us know that we have an error. That's basically bad format data entry that we're getting. So our category at the end is going to be result. In this category, it's going to be a category repository, and we're going to just save this guy as an entity, and its name, it's called category. right? So take a look again. This is basically, it's equal to insert into the table, blah blah blah, but everything is handled by who? By JPA. You're not dealing with any SQL command here. So this is very important to understand, because as our application grows, you will get to a point that you're like, I need to use all those, complex joins, but always think about JPA is the framework that's going to help you to simplify your database transaction, because I've seen that many, many, many times. Okay, so people make those mistakes. And at the end, of course, we're going to send what back? We already know. We're going to send the response entity, and we're going to craft this. And it says, what's the URL? We know the URL. It's going to basically be new URI. And our new URI, it's going to be basically /API. We know that. /category, right? We know that. This is the part that doesn't change. And then it's going to be the result.getID. Well, this is actually interesting. The result, take a look. Before we proceed, this is very interesting. Now we can actually verify that our Lombok was working. So if you recall, in category, I did not set any setter and getter, right? Nothing. I just installed Lombok and inserted in my dependency injection and used the data annotation. But what's happening in Lombok, we have access. Lombok basically generated all the getter methods. See, it's get ID. It's available here, so we have it. All right, so let's proceed. I just want to make sure you guys see this part. And this is going to be java.net. Awesome. And then this is going to be the body. And in the body, we're going to put the result, which of course it is the category that we just saved. So our repository is going to save the category that we received via this path variable, the receive with this request body, I'm sorry. And then we're going to save it, and it's going to return the category we just saved. We're going to craft a new response entity, which is consists of status code and header and body. And we're going to craft the URL. We already know the API should be at the front because we are annotating with the /API. And we already know if we want to access to a specific category, we use /category/ID. So we need to add this to the path. So /category, and then at the end, of course, plus a result.getID, and then that guy. So we're going to go ahead and test this now to see if it works. But remember, this time we have to issue a different command. So we're going to issue a get command, and we're going to copy this guy. Now this time we're going to send the post command to / and remember the post, it goes to /category, right? So it's going to be to API /category. And what's going to happen in our request body, we're going to actually send, if we go to raw data, well, we're going to send this in the request body. So we're issuing a post command to this address, and we're sending an ID of 4, and we're going to put this as I don't know, maybe healthcare expenses, right? So we're going to send the JSON. Okay, and this is going to be ID 4, and this is going to be healthcare. So I was actually I didn't pay attention to our response body. This should be on JSON.application, and now you issue, and there it is. So we created this healthcare category. Look, we got the response, which we crafted here. We returned it, and there it is. We created response. So now if I issue to category, you see the 4th one as the category we just added. So our post mapping as well as working as our get mappings. So now we're going to proceed with our next item, which is a put mapping. So put mapping, if you want to modify or if you want to basically override a category, this is the method that you can use. We're going to have category /ID, and then we're going to have a response entity again, response entity again, And this response entity, of course, is going to return the category that we're updating, update category, and it's going to receive a valid request body again, request body, and then it's going to be, of course, a category, and we're going to name it category. And if you look at this guy, now we're going to have a category, and I'm going to name it result again, and it's going to be category dot save category repository dot save and the category. So, and then at the end, we're going to return, you know the drill, response entity that okay, and we're going to put the result in body. Awesome. So category, of course. Well, here's the thing. When you save it, if you pay attention, these are both the same methods, right? But JPS is smart enough to understand, oh, if the record exists and the method is put, I'm just going to update and overwrite it. So see how easy it is. Instead of writing hundreds of lines of code to update and manipulate data in SQL databases, and then with JPA, what basically simplifies all this process. So if you go ahead, we can issue another command. Of course, this time is going to be put command for healthcare 1. I'm going to put a healthcare 1, and we're going to issue this command, and we're going to get an error. It says not supported, and so we're going to save this guy, and we're going to stop the application, and we're going to return again another Spring Boot. Let's run it again. Okay, so we're going to say put mapping. We're going to send it to an ID. I'm sorry, number 4. We should provide the ID. Perfect. Now, if you go back and issue, we should see the updated value. There it is. So our put mapping, now it's updating, it's overwriting the ID that we're sending to, and it's actually working properly. And of course, you know the drill. The last one is going to be delete mapping. This time I'm going to send it to /category, and then we're going to have an ID. So if you go, if you remember again, response entity, this is going to be a generic type, and then I'm going to have a delete category, and then it's going to be @. Since ID is going to be in the path, so it's path variable, and we know the ID type is long. And if it's so easy, now we're going to go ahead again to category repository, and we're going to tell the category repository to delete by ID, and here's the ID of our thing that we're trying to remove. And of course, once we're done with the delete operation, we're going to again, as you know, we're going to return response entity, and we're going to say if it's okay, and just build. So build basically tells don't send anything in body, just build a response body of okay, response status of okay, and send it back to the web browser. So there it is, done. We just have a mapping. We're going to go back this time, and we're going to issue a delete command. If we go back to here, so we're going to issue this time a delete command to category number 4 that we just created, and we're going to issue the request. And we are getting an error, and that's right, because it's going to be a path variable. There's not going to be anything in the body, and well, we're going to issue just this guy. We're not going to send anything in the body, so it's going to be none. Let's see what it is. No class name entity with ID 4 exists, so it's already deleted. So there it is. So we just deleted our ID number 4. Let's go issue the same command for ID number 3. Actually, I don't want to do that because I want to work with it. So you get the idea. Now we have the 3 initial IDs we have. All right, so we learned how to basically use the controller to handle all these HTTP requests, put, post, get, and delete. So our RESTful API, now we have a good understanding of RESTful API with combination of our database, functions and all those things. We talked about architecture. So the next step, we'll be working on a React application for a UI side, that a UI application will make calls to all these put, post, and delete functions, which is handled by our Springboot application, and hopefully we can finish this application. So this video is getting too long, so I would like to split it in 2 videos. So again, we went over architecture and Springboot, which is the backend and database, and designing controller. Now you have a good understanding of controller and you have enough time to practice all these concepts. In the next video, we're going to actually move faster and build all the controllers, faster than the first video. And once we have those ready, then we'll be also working on React application that will handle all the nice GUI. We'll be using Bootstrap and a lot of different libraries in our React application. I'll walk you through all the React GUI side of this application. So stay tuned, and I hope to see you next time. Bye.